No.
So subtract the cosecant x and subtract the 15. I get cosecant x plus 2 is 0. Okay? Excuse me. So in order to solve for the angle, I have to now move that 2 back over because I've got it set equal to 0. So I have cosecant of x equals negative 2. At this point, I would take my inverses. What I want to do is I want to solve this in terms of sines and cosines because it's easier to work with in your triangles and all that other fun stuff. So if I take the inverse on the left-hand side, what do I have to do to the right-hand side?
You have to divide it by.
You inverse it. Yeah. So basically, remember, you're just raising both of these to the negative 1 power. What's the inverse of cosecant?
Sine.
Sine. What's the inverse of negative 2?
1.
Negative half. So we get sine of x is negative 1/2.
If it's inverse, I thought it
It just flips the fraction. That's all you do. You're thinking perpendicular lines. We have to think opposite reciprocal.
That's opposite.
Yeah, you're thinking perpendicular. It's a very common thing for people to think about because you do that more often than you do something like this. So now you're at a spot where you guys all know what to do. What triangle am I in?
3069.
30/60.
30-degree angle, so is
Pi over 6. I'm pi over 6 and I want to be negative, so which two quadrants is sine negative?
7 pi over 6, 11 pi over.
Very good, very good. Third and fourth quadrant, 7 pi over 6, 11 pi over 6. This was a, did it say one revolution on this one or general? One revolution. Now, what would be different if this problem asked you to write it in terms of a general solution? For this scenario, it would be plus 2 pi n because there's no way for us to get from here to here and back to there at the same interval, so you have to just tack on 2 pi n each time for the general solution for this problem. Yes?
No, I have to copy it off of this paper.
Are you kidding me? You copied.
She's copying. This is going down on your permanent record.
I copied off myself. Is that
Yeah.
the back of the
So, what I'm going to have you, I'm going to give you guys time now, but I also want to talk a little bit about that quiz there. I want you to do that middle grouping, 3 through 12. It's just working with some inverse problems.
3 through 12?
Yeah.
Not including 7.
Oh, yeah, you don't have to work on 7, just did it. So I want you to do 3 through 12, but I also want to talk a little bit about
Oh, you're supposed to.
your verify from last night. So let's take a look at the verify from last night.
Verify last night?
Yesterday, whatever it was. When you're talking about verify,
No, I'm.
when you're talking about verify, one of the easier things to do when you see parentheses is think about order of operations. Go inside the order of operations to take care of that right off the bat. And remember, in this case here, you've got cotangent, which is cosine over sine, and it's being divided by 1 over cosine, which is times cosine over 1. You get cosine squared over sine plus 1 over sine. And it's all being times sine. So when you distribute the sine, what happens to the sines in the denominator?
They go away.
Cosine plus 1. Cosine squared plus 1, excuse me. And you're done. And you're done. It's that, I mean, I think all of these were 3 steps. Second one. We have secant over cosine minus tangent over cotangent is 1. Cosine is the inverse of secant. So that's the same thing as saying secant times secant, so you get secant squared. Cotangent is the inverse of tangent, so, or 1 over cotangent, so you get minus tangent squared. Oh, secant squared minus tangent squared. Oh, that's right, it is 1, and you're done.
I
I thought for some weird reason.
The idea of doing that is that you could have set it up secant times 1 over cosine gives you secant times secant. Same thing on the other one. Tangent times 1 over cotangent is tangent times tangent. That's where you can show it that way as well. Yes, sir.
Okay, I feel like I'm confusing myself on the whole diagram. Secant would be minus 1 over cosine.
Correct. So you could have done it that way and gotten 1 over cosine squared minus 1 over cotangent squared, which would have brought you back up to secant squared minus tangent squared, which is still equal to 1. It's knowing the Pythagorean triples, not triple, Pythagorean identities of those of sine squared plus cosine squared to allow you to remember that it was tangent squared plus 1 is secant squared. So should have been very, very, very fast. There's other ways of doing it. Some of you guys went the real long way of doing it. Some people did it a very short way.
People didn't get it at all.
Some people didn't get it at all. Okay. Just so you know how that one works. Now, as far as the test is concerned for Thursday then.
Oh.
Tuesday.
We had a quiz on that stuff. We don't need to know.
Go back to that quiz you guys took prior to spring break. You guys all kicked some serious butt on that quiz. You did really, really well on that. So that was the 40.1 right before break. I wasn't able to get the grades inputted until like the day before. We came back from school, or came back from break because Skyward was down that whole time. So the graphing, amplitude, period stuff, revisit what it means to how do you find the amplitude, how do you find the period, sines, cosines, how do you set up your shifts. What I'm thinking,
Will we do this tomorrow as well? Like traffic,
yeah, I will be more than happy to do a couple examples of stuff like that. Simplify, verify, I don't think I can explain any more about what it looks like. You guys have all been doing that for a while. We've been working on that for about a week. Solving generals, solving intervals, as you've seen, it is relatively straightforward. There's not a lot of craziness involved here. The test itself, I think it's about 10, 11 questions tops. It shouldn't take, it should be, it's very straightforward. There's no tricks, there's no nothing. There's nothing that you haven't seen. Obviously it might be a different problem, but it's of the same complexity of everything that we've been working on. There's no curveballs, there's no nothing there. All right. I figured with the half day then on Friday, we will look at the 14.5 stuff, which is looking at a graph of a trig function and writing the equation from the graph, figuring out the h and k that way. It's a little bit more complicated. I figured it's something we can do in half a period, finish it on Monday and call it a day, since we've got some really weird schedules the next week.
Not Tuesday, Wednesday,
Tuesday and Wednesday of next week, we'll start with conics. Tuesday and Wednesday, we'll probably do the two sections right off the bat. 10-1, 10-2 are very, very simple. 10-1 is distance and midpoint. Yeah. I don't even think I'm going to bother with it. I think I'm just going to go right to 10-2, which is parabolas. And we're going to write parabolas a little bit differently than what you guys are accustomed to from previous stuff, where you graph them out of ax squared plus bx plus c. We're going to write them a little bit differently. Okay? Use this time now. If you got questions on the equations, I'll wander around and go with it, but just want to give you guys a heads up of where we're at as far as the test and all that.